Hello guys, let's see the question number 9. In question number 9 we have to find out the reactant or the catalyst which by which we can get this product. So which catalyst is possible? So what, first of all we have to understand how this reactant is converting in product. So in reactant there is a carbonyl group, and this carbonyl group gets converted into CH2 group. So LiLH4 cannot be possible and NaBH4 not possible, because LiLH4 and NaBH4 both reducing agents converts carbonyl group into alcohol. So only it is possible with Clemmensen reduction and Wolff-Kishner reduction. But we know that it is a ether, and actually cyclic ether or ether are unstable in acidic condition, and in Clemmensen reduction we use zinc amalgam with HCl. So HCl is actually acidic condition, so it is a acid. In acid this cannot be written because it will be reactive. Ether are reactive towards acid, so we should avoid the Clemmensen reduction. Now Wolff-Kishner reduction. In Wolff-Kishner reduction we use NH2, then ethylene glycol, KOH in ethylene glycol, KOH in ethylene glycol, ethylene glycol. Here we are using base, and ether are stable in a base, so it does not react with base, so we can use Wolff-Kishner reduction. So our answer will be B. In next question we have to find out the increasing order of equilibrium constant for the formation of hydrate. Now understand what is the meaning of hydrate. In hydrate actually carbonyl group react with water, and water behave like as a nucleophile which will attack on carbonyl carbon, because electron of pi bond would be shifted toward oxygen, and hence oxygen will be negatively charged and carbon will be positive charge. So it is a type of nucleophilic addition reaction. Now we have to understand equilibrium constant like Kc or Kp depend upon the concentration of product divided by concentration of reactant. So if concentration of product will be higher at equilibrium, then equilibrium constant will also higher. So it means if hydrate formation is higher, then Kc or equilibrium constant will also be higher. Now hydrate formation will be higher in that case where nucleophile will attack on this carbonyl carbon with fast rate of reaction, means it should be faster. Now the attack of nucleophile on this positively charged carbocation depend upon the intensity of positive charge which is present on carbonyl carbon. If positive charge on carbonyl carbon is increased, so nucleophile will do faster attack on this carbonyl carbon, so our equilibrium constant will also be high. So the factors which increase the positivity, which increase the positive charge on carbonyl carbon, these all factors will increase the equilibrium constant of this reaction, means hydrate formation. So what are the factors? Factors are like, suppose there is NO2 group is present, and we all know NO2 group will show minus R effect, so it is actually electron withdrawing group. So it is electron withdrawing group, hence it will increase the positive charge on this carbonyl carbon. So when positive charge on carbonyl carbon will increase, so nucleophile will attack faster. So hydrate formation will be increased, or rate of reaction of hydrate formation will be increased, hence equilibrium constant value will also increase. Then it is a neutral, no electron releasing group, or neither electron releasing group nor electron withdrawing group is attached in third molecule. In second molecule NH2 is attached. Now what is NH2? NH2 is actually electron releasing group. It is a electron releasing group, so it releases the electron plus R effect. That's why it decreases the positive charge on carbocation. So actually value of Kc will also be lower. So what will be our answer? Our answer will be C. Fourth, then third, then neutral. Neutral means that is third is your neutral. Then second, after that first. That will be our answer. Then question number 11. That is a actually mechanism based question in which we know when hydration of alkyne occurs, then there is a formation of non-classical carbocation like C double bond C, OCH3 and Hg plus 2 ion will be make a ring like here. Now in second step, that is a rate determining step. In second step, water molecule or H2SO4 molecule as a nucleophile will attack on this carbon. This bond will be break. Why it will attack on this carbon? Because if positive charge will occur on this carbon, suppose positive charge will occurs on this carbon, this type of carbocation, that is partial carbocation, it is more stable comparatively to present on one number carbon. That is one number carbon, that is two number carbon. So if positive charge occurs on two number carbon, it is more stable carbocation because there is OH3 group, OCH3 group is attached, which have minus R effect as well as plus I effect, minus I effect, sorry, plus R effect. Minus I and plus R is dominating effect. So due to plus R effect, it will stabilize the carbocation. That's why if carbocation positive charge occurs on two number carbon, it is more stable. That's why nucleophile will attack on two number carbon. So our product will be like that, C double bond C, and there is OH. Then OCH3. Now ketoenol tautomerism occurs, and due to ketoenol tautomerism, this double bond will migrate and our product will be C. So its answer will be C. Now we have to find out the product of hydrolysis of this molecule. So what may be the product of hydrolysis of this molecule? So when we hydrolyze this molecule, then what happen? We can understand which group will be hydrolyzed. Actually, it is like an ester. C double bond O, then O, and then R. That is R. That is also R. So it is actually ester. R, C double bond O, O, and then that is R. So that whole is a part of ester. That is also ester. So what happen if ester is hydrolyzed? We know then the product of hydrolysis are carboxylic acid as well as alcohol. So what happen? This bond will be break and we will get carboxylic acid like that. This bond will be break as well as this bond will be break and we will get carboxylic acid and alcohol. So carboxylic acid like C double OH and C double OH, that carboxylic acid we will get, and this type of alcohol we also get, OH and OH. Now further, after dehydration, this product can convert into ketone. This product can convert into ketone. So which product will be formed? We have to find out which product will be formed. Now what happened? This molecule, that molecule again react with water. So like this, COOH and COOH, and the bond of carbon will be break, and electron will be transferred toward this carbon. So this carbon will be positively charged. So water will be attack on this carbon. So water will be attack as a nucleophile on this carbon, and ring opening will take place because three-membered ring are unstable, and we will get a molecule is like that: OH, C double bond O, CH, COOH, CH2 twice, and OH. We will get this product, and when carboxylic acid and alcohol react together, they will form a ester as well as five-membered ring. So they will form ester as well as five-membered ring. So here will be oxygen, double bond O, and one COOH. That COOH will remain here, COOH. So our answer will be C. C will be our answer. In question number 13, we have to find out which method is correct for this conversion, means by which method we can proceed this conversion. So in this question we know answer will be, that is B, because first of all this propanone will react in the presence of acid, and it will form a compound is like that. This compound will form O, then O, then this compound will form, and when it will treat with KMnO4, then here is OH. This OH group will convert into carbonyl group, and further our product will be like that: double bond O and oxygen. Now if we hydrolyze this compound, finally we will get our product. So our product will be like that: double bond O and OH. So that will be correct sequence by which we can proceed this conversion. Next one is 14 question. Compound A and B can be differentiated by. Now first of all we have to know what are compound A and compound B. So we can understand what we are doing. We are doing hydrolysis. If we do hydrolysis of ether, and that is a type of ether. So when we do hydrolysis of this ether, then we will get two compound. First one is, that is CH3 CH2 CHO. First one is CH3 CH2 and CHO. That is compound A. After hydrolysis of this ether, and the compound B will be propanone. So that is CH3 C double bond O and CH3. These are actually A and B, which we will get from hydrolysis of this ether. Now propanone as well as aldehyde both can give 2,4-DNP test, so we can't use A. That aldehyde and ketone, yes, aldehyde and ketone can be distinguished by Fehling solution, Benedict solutions, shift test. So answer will be B, Lucas reagent, known Lucas reagent we can't use. Why? Because it is used to distinguish between 1 degree, 2 degree and 3 degree alcohol. NaHSO3, no, we can't use. So your answer will be option B. Thank you.